for vertical motion. Okay, so first graph which we will see is the first graph which we will see. First we will see position time graph. Okay, so suppose an object is thrown up. We are starting, means we are taking a condition, object thrown up, object thrown up with speed u. So how will the graph look like? So initially the speed will be what? U, means there will be some positive slope and displacement will be 0. So graph will start from here with positive slope. Why positive slope? Because u is there, the positive value, and slowly after some time the position will be keep on starting from 0. Position will keep on increasing, and velocity is decreasing. At highest point velocity has become 0. At this point velocity has become 0, the slope has become 0, and the particle is now returning towards ground. Velocity is negative, and finally velocity is negative, and finally the object is on the ground. So what we can show here is, here velocity is positive, here v is negative, and here this is corresponding to highest point, and velocity here is 0. And since the graph is inverted, this is the negative acceleration. The whole system is negatively accelerated. That we know. For gravity the acceleration is downward, so we can say it negative if we have taken upward as positive. So A is negative for whole system, and this graph looks parabolic. This graph is parabolic in shape. Why parabolic? Because there is S and T are related. The S and T are related with this relation. This is square, T is square and S is single power. So this graph gives what? Parabolic relation. So this is a parabola. Okay, one more graph I will show about the gravity. If instead of this was S was displacement, this S was displacement. If we instead of displacement, if you consider distance, how is it going to change? If you consider the distance instead of displacement, then if you consider distance for the same graph, for the same motion, if you consider distance instead of displacement, suppose S is now distance, then what will happen? That initially graph will be similar up to highest point, but after this point the distance is still increasing. So graph will go like this. So after this point you can see object is returning back. So as object is returning back, displacement is becoming less and less from the beginning point. But distance is what? It is the path traveled. So path traveled is still increasing. So distance can never be decrease. Once you have covered a distance, suppose 20 meter, you cannot cover a distance of 19 meter or less than 20 after that time. Means, for example, I am giving example of a car. If a car has traveled suppose 2000 kilometers at a particular time, then in any future time it can never have a reading less than 2000. It will always have more than 2000. So distance traveled is always increasing. So the same graph which was going downward, that will be taken as upward. Okay, and the graph will be changed accordingly. The distance traveled is always like this. Here the distance traveled, the rate of distance traveled is 0 at this point. Then again it starts increasing. So this is a distance time graph for gravity. Next we will see velocity time graph. Velocity VT graph. So if you consider VT graph, initially velocity is what? Positive, and it decreases to 0. It decreases to 0 at uniform rate. It strikes the ground. After striking the ground, its velocity becomes positive suddenly. again it goes to this point, and maybe its velocity is not same as the initial value. It may lose some of its energy. See what is happening. Velocity started with this point, and here velocity becomes 0. But after striking the ground, its velocity is what? It strikes the ground and its velocity is, sorry, 1 minute, one correction is there. Okay, so this line will be extended further because at highest point velocity is 0. Now its velocity becomes negative. This kind of graph, it will be going like this, and see, its graph will look like this. So velocity started with positive value. At highest point velocity became 0, and then it started become negative, and at lowest point when it is going to strike the ground, velocity is negative. Then suddenly after striking the ground, what will happen? The object strikes the ground, the object is going up, then returns back, then it strikes the ground, and after striking its velocity becomes what? Again positive. Suddenly its velocity becomes positive. So again it will be behaving like this second time. Though what happened, that its velocity became positive, and this time velocity may not be the initial velocity because after collision it may lose some of its energy, and then it again starts going up, 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 and going to highest point. This is corresponding to highest point. This is also highest point, and then it is going to negative and reaching to ground. This point 2 corresponds to ground. This is corresponding to ground. This corresponds to ground, and then again it collides with the ground, and then again graph will like this. So it will keep on repeating like this until the ball finally stops on the ground. So this kind of graph you can draw for velocity time. And if you want to change this graph for speed time, so how will it change? If you want to change this graph for speed time, the changes which we have to make it, the changes which we need to make is the graphs which are going on the lower side. Since speed cannot be negative, you have to take the mode of this. Mode of this means the whole thing will become positive. So all the things which are on the lower side will become positive. So we can do it like this. We can take it like this, and we can invert it. Like this. Okay. No problem. Okay. Take. Okay. So I am drawing it separately. The graph will be looking like this. Graph will be looking like this, and here also. So this is speed time graph. Last one was the velocity time graph. This is speed time graph. And what about acceleration time graph? Acceleration time graph will always be same. Acceleration time graph is not going to change. If you write acceleration time graph, it is going to be constant, negative constant, minus g. So it will be like this. Okay, one more graph we can draw. That is okay. In this one, after collision, it will again go like this. After collision, second time, the displacement graph after the collision with the ground, it may go like this. Okay. One more graph we can draw is displacement and velocity graph. VS graph. Okay. So how will the VS graph will look like? So we know that V and S are related by this formula, V square minus U square equal to 2AS. So V and S for a constant acceleration are related with a square relation. So they will not be linearly changing. And if you want to draw the graph, so how will the graph look like? Initially the velocity was what? Some positive value, and displacement was 0. So starting from here, and as displacement is becoming positive, means as object is going up, velocity is becoming 0. So object may go like this, and after this point velocity starts becoming this is the highest point. This is, suppose we call it H. Object started from here. At this point the velocity is some positive value and displacement is 0, and after this point it goes like this. At this point the object reaches to highest point, this is highest, and displacement is maximum, but velocity has become 0. Now velocity starts become negative, and it goes like this. This is parabolic in shape. Why? Because V square and S relation. And finally at this point it will reach here. This is the point corresponding to ground. Why ground? Because you can see the displacement has become 0 at this point and velocity has become negative. As it strikes the ground, its velocity will suddenly become positive after collision with ground, but that velocity will be little bit less than the initial velocity, because it loses some of the energy. So suddenly it will jump here, and then again it repeats. This time the height covered will be less than the previous height. Then again goes like this, then again it collides, then it starts from here. So graph will look like this, and finally object comes to rest when this graph converges to origin.